Hello, greetings, Module 3 screencast for Jeff Chin. I teach 10th grade chemistry. So let's get going. First, part of the assignment was end of the chapter questions in Barrel's book. So I chose for the first chapter, what are the steps of problem-based learning? And in essence, there's 7 steps. So the first one is you have to have a problem statement, usually in scenario form. Like part of the videos we watched, their question was, why is the butterfly population going down? From when I used to live in the Bay Area, how can we alleviate traffic in downtown areas? For us in San Diego, how can we clean up our beaches or oceans? And for us as just global citizens, how do we stop global warming? So first of all, you have to have a problem statement. So number 2, collaboration. So students are divided into small groups, and when they're divided into small groups, they get various roles assumed by the students, which are identified. So you can have a scribe, you can have a researcher, a manager, but everyone has to have a position or a job description. So number 3, after they get into the collaborative groups, they brainstorm, and the reasons why they brainstorm is because they got to know what they already know, what each of them already knows. So it gives them an opportunity to analyze the situation. In doing so, they can raise questions, and when they raise questions, they access prior knowledge. So step number 4, they investigate. This is the doing part. They search for the answers to their brainstorming questions that they got in number 3. So they make connections to prior knowledge, and then they go to step number 5. Critical analysis. They reflect on your group findings, and you draw some reasonable conclusions to your main problem. So in this critical analysis, they should be answering the problem-based or the scenario-based question. Why are the butterflies going away? They should have some answer by this point. And then you share your findings. In doing this, you have presentations to informed audiences, to your peers, and the last step, you get assessed. So there's various kinds of assessment. There's informal and formal. It has to be authentic, and it's by students and teachers. Moving on. So those were the steps. Now we go to chapter 2. Why does Barrow believe that risk is one of the most difficult aspects of problem-based learning? Do you agree? Why or why not? So I do agree that risk is the most difficult, and because it requires students to give complete trust to the teacher and to the class environment. There's lots of answers to questions, or lots of answers to questions will be not the correct one. That's part of brainstorming, because you're just throwing things out there. But what doesn't stick to the wall helps you, because you know it's not the right answer, so you can check it off the list. And in this case, you know, in problem-based learning or inquiry-based learning, students are the investigators or the scientists, and that's usually trial and error. So error, you have to have a really good psyche to be wrong. So students must feel secure that they can be wrong without the normal teenage scrutiny. And this cannot be taught. It has to be earned. Excuse me. And it's earned through classroom discourse and culturally relevant teaching. So, and those things are hard to do, because those are active processes that the teacher has to complete on a daily basis. So let's moving on. What does Barrow mean by curriculum that is boundaryless? First, we want to define boundaryless. So there are no traditional lines of authority among leaders, managers, and employees in order to get the best minds working on complex problems. That's what the CEO was talking about when he came up with boundaryless. Here, you have to establish an environment that welcomes questioning. And you have to have different points of view are encouraged and embraced. And lastly, it thrives on collaboration among all participants. So that's what boundaryless means in our curriculum. Having a good classroom environment that welcomes questioning, different points of view are encouraged and embraced, and it thrives on collaboration among all participants. Third chapter. Craft your own definition is what is meant by problem-based learning. So my definition, first, if I was going to tell another teacher, PBL is a learner-centered instructional method that has roots in both information processing theory and social constructivist theory. Students are provided ill-structured problems that mimic real-world issues on collaboratively in small groups use prior knowledge, self-directed learning, and intrinsic motivation to solve the problem. The result is new flexible knowledge. That's important, the flexible knowledge gained by using metacognitive skills and awareness across multiple domains. And lastly, it's a hands-on approach to learning and sustained inquiry. I like sustained inquiry because that's part of that design thinking we read about, in which knowledge is constantly being questioned and acquired. So that's my definition of that. Next, distinguish how problem-based learning is same or different from project-based learning. I feel, in general, problem-based learning and project-based learning are exactly the same. I feel, in order to be effective in achieving their goals, I feel they must accomplish the same things. And there's a gold standard that that one website had that I'm going to draw from. So you have to include a challenging problem or question in both of them. You have to have sustained inquiry. It has to be authentic. Has to include student voice and choice. They have to allow for student reflection. They all include critique of student work and time for revisions, and they produce a product or answer to the main question or challenge. Both problem-based learning and project-based learning do these, and at their core, they're just the same to me. If all 7 of these gold standards are achieved, you can name it whatever you want. You know, there was X-based learning because they had game-based learning, they had inquiry-based learning, they had all those basic learning things. But for the sake of all things researchable, I came up with this little thing right here. So it kind of gave the small differences. And in a nutshell, problem-based learning over here on this side is more for specific problems and for just one, like, classroom. So it wouldn't be a school based project, which would include the chemistry, the social sciences, and then the ELA. All 3 of those guys would be gathering together to do a project-based learning project. But me, just in chemistry, I could come up with a problem-based learning, like, why is the ocean becoming acidic? You know, something like that. And it would be just specific to me. So moving forward, identify how teachers can infuse student inquiry into their curriculum and turn students' questions into instructional units. Well, you have to tease out various lines of inquiry that capture student interest. And one of the things that I found in the research was a wonder wall. You put it up there and students write their questions down, and it gives you a nice place to capture things so that as a teacher you can do the next thing, which is those responses will allow teachers to see what topics or angles students are really inquisitive about as they plan lessons to harness that curiosity. 3, you have to find an avenue that channels this inquiry and give them opportunities to explore. And number 4, teachers always need to guide the inquiry toward further learning and keep students from being sidetracked. It's not a free-for-all. This means you have to keep the learning objectives as the ultimate goal. And for me, the learning objectives are always the key knowledge that I want them to know, success skills, the skills that will give them success as 21st century students or 21st century citizens, and just understanding. And when you understand something, that means you can take it, put it in your mind, turn it around 3 or 4 times, and then use it to basically anything you want to. So that's it. Thank you for listening. Thank you. And we'll see you next time.